Electrolysis. Electrolytic cells use electrical energy to produce chemical changes. When we talk about electrolysis, electrolysis forces an electric current through a cell to produce a chemical change for which the cell potential is negative. And remember, if the cell potential is negative, we're looking at a non-spontaneous process. So electrolysis causes a non-spontaneous chemical reaction to occur. Now we want to look at a couple of definitions before we go into an example of a problem. So we need to know what an amp is. So an amp equals 1 coulomb per second. And we also need to know that 96,485 coulombs equals 1 mole of electrons. Electroplating. I want you to take out your standard reduction potential tables and look up the value for the reduction of copper 2 ions. And we should get a positive 0.34 volts. And then there's standard reduction potential value for the reduction of zinc ions. And we get a negative 0.76 volts. And remember, when we look at the standard reduction potential table, we can decide which is more likely to be reduced. The more positive the standard reduction potential, the more likely a species is to be reduced. So in this case, copper ions are more likely to be reduced, whereas zinc atoms are more likely to be oxidized. So if we were to look at a voltaic cell, which is a spontaneous process, we would have zinc atoms being oxidized to zinc ions and generating electrons, and those electrons are going to be used by the copper ions to reduce them to copper atoms. And that would be a spontaneous process, because if we were to take the reduction potential for the reduction and minus the reduction potential for the oxidation, we would get a positive value. An electrolytic cell would just be the reverse. We would be taking the substance that's least likely to be oxidized, running an electric current through it and causing it to be oxidized. So in this case, or to be reduced. So in this case, our zinc is going to be reduced from zinc ions to zinc atoms, and our copper atoms are going to be oxidized to copper ions. But the only way this process is going to be able to take place is if an electric current is added into the cell, which then will cause that non-spontaneous chemical reaction to occur. So let's look at a problem. We want to determine the mass of copper that's plated out when a 10 amp electric current is passed for 30 minutes through a solution containing copper ions. So in other words, our copper ions are going to gain electrons and become copper atoms. They're going to plate out onto our copper electrode and increase the mass. We want to find out what the mass of that excess copper on our copper electrode will be. So what we would do here is we would start with 30 minutes, and we're going to want to convert that from minutes to seconds. So we know that for every 1 minute, we have 60 seconds. Now we look at our amps. We've got 10 amps of current, which means that we've got 10 coulombs per second flowing through our cell. Now we can go from coulombs to moles of electrons, because we know that there's 96,485 coulombs for every mole of electrons. Now for this particular problem, we're going from copper 2 ions to copper atoms, so that means we need 2 electrons. So for every 2 moles of electrons, we're going to produce 1 mole of copper plated out. We want grams, so our last step, for every 1 mole of copper that's plated out, we're going to have 63.55 grams of copper. That's going to give us 5.93 grams of copper that would be plated out of a copper ion solution when 10 amps is run through that solution for 30 minutes. Let's look at one more problem. How long must a current of 5 amps be applied to a solution of silver ions to produce 10.5 grams of silver metal? So this time we have the grams of metal that we want to plate, and we want to work the problem backwards to find out the time. So we have 10.5 grams of silver, which we're going to want to convert to moles. So we've got 107.86 grams of silver for every 1 mole of silver. And then we know that silver has a +1 charge. So that means that for every 1 mole of silver, we're going to need 1 mole of electrons. We can then go to coulombs because we know that 1 mole of electrons is equivalent to 96,485 coulombs. We can next look at our amps, and we know that 5.00 coulombs is going to flow per second, since we've got a 5.00 amp current. And then because we're going to be working with big numbers, let's get that to minutes. So we've got 60 seconds in 1 minute. So when we plug that into the calculator, we're going to get 31.3 minutes. That means that if we want to plate out 10.5 grams of silver metal from a silver ion solution using a 5.00 amp current, we would have to run that current through the solution for 31.3 minutes in order to achieve that much silver plating.